using Clay to find and categorize any data point or insight. That is something I believe is an absolute incredible unlock that's possible to build with Clay. And I did a posting on LinkedIn that just gives a 30,000 feet view on that. But here I want to show how I built the workflow. This is the end result. We take the domain of a target account as input, and the output we want, because this will be the snippet we will use in the outbound messaging, is the top category this target account is actually working on. So in the case of a architectural company, that will look like this. So I'm using as an example, because they are nice and visual, Bond-Brine. This is the website of Bond-Brine. Of course, this is what a person would do, would go to projects, look at which projects are they working on, and especially when you're my client, you know which of these projects is the most meaningful to reach out about. So cool, they are working on blue light. That's an industry term for something, I'm not sure. So they are working on blue light, but we don't do blue light visualization, so that's not interesting. But oh wow, cool, they work on master planning. Master planning is our specialization. That's the one we want to reach out to about them. And there's a lot going in there. We see here projects, master planning, that is in fact what my client wants to have as a final insight about this account, and that is also in fact what we are seeing. And I built a workflow that leads to a very high correctness or accuracy of that. The interesting thing about it, which goes beyond Clay, is this is not a binary example. So there may be degrees of interpretation, because companies or their target accounts talk in thousands of different ways about how they call the projects, right? And that is why I would argue when 3 people on the client side come to that determination, they may not always be 100% in agreement. So this is why it's also important to consider, I think there's always 2 major results from data gathering workflows like this. Either the result is binary, so for example, is a company SOC 2 compliant? Yes, no, that's a yes or a no, right? But in this case, there can be a little bit of variance, so that needs to be taken into consideration when actually judging the results of the workflow. But no further ado, this is what this type of company project build looks like. The approach I'm using, I'm going over it once and then I'm going to go into the details. I always try to start from what is the truest data I can find. What is the truest source I can find? And one thing that I have learned is that still nobody's better than Google to find relevant stuff. You just need to know how and where to look for it. So what I did is, I don't know if you can hear the sirens, that's New York. So what I did was I used ChatGPT to come up with the major search terms that I would need to use in order to find the main projects page of a company like this. And that turns out to be searching for the company name, then services or projects or portfolio. So what I'm doing is I'm normalizing the domain. I'm searching only on that site for services or projects or portfolio. That search result, because it will lead to up to 10 organic results. Those organic results will not always be that the best website to look at is the first result. And that's important for workflow mechanics. What I'm doing is I'm throwing a very cheap model, Haiku, at those search result URLs and have the Haiku determine which is in fact the main projects page, because it could be like page 10 or it could be like otherwise a news article about the project because that ranks higher. There's a lot of fuzziness when you have to go for the first result only. And I mitigate that with having Haiku actually analyze the organic search results that I get, the URLs that I get. Actually, it doesn't look at the sites. And then I'm using that further down the road of the workflow. What happens next, and maybe that was already too detailed, what happens next is that I'm using a Sonnet. I tried it with much cheaper models, but they did not come to good results, maybe because of the complexity of the websites. I'm using a Sonnet to basically scrape that result. First step, find the best source. Second step, scraping that result, understanding what's on there. This is this step, finding the company project categorization. Then, very important, my client doesn't want to talk about just in any terms about this, but for example, and now I'm missing the examples, but like all the things, so for example, hotels and resorts, or hotels or resorts or theme parks or whatever, that all should go under the main category, leisure and hospitality. And this is like another quote-unquote translation step that happens from all the results, all the categories that we find. We want to match this large number of categories to a smaller number of wider major categories. And here I actually did something that I would say was an interesting try, but too expensive to run at scale. I actually used a Sonnet to do that mapping of the large number of entities to a smaller number of entities, because my brain went to, oh, there needs to be so much understanding of blah, blah, blah. But that's actually not the case. So what I ended up doing, and this is not in this view, I will have to change that in a second, but I actually ended up to use one of the, it feels like stealing to do this, because you can actually do that with a formula at absolutely no cost. And I'm going to show this. And then we come to a much smaller number of major categories, and then we make a determination which of these categories has the highest priority, and this is the output you saw in the beginning that will come up here. Let's get into it. Let me show the details. I will have to change a few things in this view. So first, company domain. Normalize domain, I actually don't know why I did that. Oh yeah, so the domain doesn't have the www and everything. And the way it works, it's always so easy to say, oh yeah, just do this, just do that, but I really want to go through it. This is a formula. Obviously the formula exists here, but the way you do it, insert formula, or you do that with add column, but I'm going to do it right here in the workflow. Where are we? Okay, so insert formula, and then basically you tap the generate formula and you tell this prompt what kind of formula you want to write. Actually, that's not right. I said the wrong thing. In this case, I just want text. Oh, actually, sorry, I think I was confusing the terms. So what I want to do is I want to do a Google search with a specific search term. This is what I want to do. I'm using a custom API, which is Serper, 50,000 Google searches for $50, so really, really cheap. And in order to get that working properly, you need to feed it the exact search term you want to use. And the search term I want to use is site, and then I'm dropping in the domain of the company, and then the three search terms: services or projects or portfolio. This is how that looks. This is a better way to show it. So it's just a text column, which gives me exactly the search term, how I want to plug it into Google. Site colon, normalized URL, and then da-da-da-da-da. For me, I've made the experience that using the actual domain in a search term versus the company name leads to a little bit better results, because when the name is a little bit ambiguous, you usually get the results that are actually from the company. So this leads to much higher quality results, because you look directly on the web page and you find those terms on that company's webpage programmatically. This is, oh yeah, I just showed that. This is the setup of the search term. This is how the custom API looks. And There are always so many levels to go deeper in this, so I think API integration would be a different video, but let's just say the API integration is set up. If there are any questions around that, just reach out on LinkedIn. But basically, this is how this API is structured, and it needs to be fed the search term, and this is why I link to the text field that I mentioned here. This will produce results, and it looks like this. 200 just means it was successful, and organic, inorganic, nested are all the results that have been found. And in many cases, the first result is in fact the website we are looking for. In many cases, it's not. And what I'm doing here is, because it's so cheap, like literally like fractions of pennies, even when you run it for 100,000, it's still going to be like $3 or something. And this is a prompt that I'm using. So using a Haiku with my own API key, and I instructed that it is an expert in data analysis and has deep knowledge of how URLs are structured. So the LLM knows in which like part of its world knowledge to look for connections. The instruction is, your task is to identify URLs that are likely to be websites that are the main URL for a subpage of that website. I don't know if that makes sense to a human, but like it's a very structured way of showing what I want. I provide a positive example, company.com/projects versus company.com/projects/listings/786, whatever. And then I want only the most likely URL that is the main page for all the projects. It can only be one URL. I'm giving it a little bit of context, and then I drop the data. Quickly want to show this once. And this is the unlock here, right? I'm not pointing it, I'm not just using the first organic result, but I'm in fact using like all of the results, and have an LLM look at the URLs and understand which one fulfills the criteria that I laid out. So what I want to do is, this is the first search results. Where is it? Search results, search project, subpage, and then you add all the organics, and this is the data the LLM will look at. This is the produced output. In most of the cases, this is exactly the web page we want to get the data from. This is what happens next. The next step is to actually do something with that source data that we got. And in my case, I'm using a Sonnet in order to find those categories. I did a lot of experimentation with Haiku and GPT 3.5, which are always my go-to models to start. But even with a lot of experimentation around the prompts, I could not get it to produce results that were usable at scale. So sometimes you just have to bite the bullet, or however that's called, and just use a more expensive model. The business case for a list like this should warrant using an expensive model here or there. It's always better to get results more cheaply, but sometimes it would be too all over the place. And what happens here is, this is like, it's also not about prompting this clip, so I don't want to go too detailed into that, but basically you're an expert in architecture and architectural design, and then I want your task is to find all types of projects a company has on their portfolio. Look for overall categories. It's not interesting to know it's like a specific project. I only want broad categories. And then I pointed directly to the URL that I found with my Google step. And what I found is that when you take out of the prompt to have the scraper find the best source, when you know where the best source is, I found it better to feed it that source coming from a different step versus confusing the Claygent or whatever you're using for that to even find that source. What I'm doing then is something where I needed input from the client, because companies talk about what they are working on. They have no rules how they should talk about it, right? So it's all over the place. In order to narrow it down to one category we need in the end, this is the process I'm actually taking. And let me go quickly to this here. What I'm doing, let me make myself smaller. What I'm doing is I find the best source. I capture all of the categories, which I restrain a little bit, that I only provided the list of like 140 categories, and the AI needs to make a judgment which of the terms it finds go into one of these 140 categories. So this I'm gonna let do by HI. So for example, it would like schools and kindergartens, it would know to make it into education and stuff like that, right? Then we want the categories we find, put them in major categories, select the best category, and then use that for messaging. And in order to achieve this, what I'm doing here is I'm feeding that first step that looks at the source and finds the first round of categories. I'm not only feeding it the source, but also a list of subcategories I wanted to pick from. And to show it, this is here. This is just, it's kind of a little bit of like RAG, retrieval augmented generation. I mean, it's really a poor man's version of RAG, but it gets the job done. So this is categories that my client provided. I helped them a little bit with like coming up with what AI finds, and ChatGPT helped a little. But in the end, that's the major, the subcategories we are looking at. So what that means is that what Claygent finds on the source pages will be one of these subcategories. That's already an important step. Why is that important? And here I think I have to click around a little bit in the workflow. I will do this now. Okay, so now change the view a little bit. So here's what I want to say that I did wrong in the beginning. What I did wrong was to take the long list of categories and use Sonnet, because the cheaper models also didn't produce good results, to condense that into smaller categories. So you have to imagine 150 categories, you want to get that down to 12. And that step I had done with Sonnet. It was a super elaborate prompt. I thought I'm doing a good thing there. You're a helpful data research assistant, accuracy extremely important, get this comma separated, subcategories list and map them into 6 main categories. This is the input, or actually the number 6 is wrong. That seems to be also a mistake that I made. Anyways, this is this is producing really good results, but it's very expensive. It costs sometimes like 30 cents, I think, per row, and that's just prohibitively expensive. So I needed to find a different way for that. And here, one step is really important, which is when you ask AI to just make sense of stuff, but you want a very specific output, that's in all likelihood not going to work. And if it works in one run, it will not work in the next run, because it's non-deterministic. So when you get a correct result now, you may not get a correct result in half a minute or in the next run. So that's not really dependable. So what I did was to feed this a lot of data. These are the main output categories I'm looking for. And again, my mistake is that I had it even at 6. That's very confusing to the LLM. But anyways, it was robust enough. These are the output categories I want. And these are the categories that will be in the data and how they should be mapped to the output categories. This is a good example. So for example, housing complexes, if that is found in the source data, that should be transformed into residential development. If it's luxury developments, that should be mapped into residential development, and so on and so on. This is key. Getting this insight from my client, because they are the subject matter experts on this, helps to make this deterministic. Otherwise, it would be all over the place. And the mistake I made was using actually an LLM for this. But incredibly, there is a version of that that is completely free, and that's using formula. And I want to show that. Actually, let me hide this. And the formula does what I tried to do with the LLM. And the unlock for me to think about it was, hey, I have something very prescriptive. I know a given set of inputs. I want to map that given set of inputs to a given set of outputs, and there's no intelligence needed in between. That is a very easy mapping. And this is the, like, how I did it. You add a formula and then use AI. And this is actually a very simple prompt for that formula. Get result, meaning get and then the result of the initial scraping of the initial large list of categories. Look at that and then map the values from there per the mapping below. Master planning goes to master planning, urban renewal projects goes to urban design, and so on and so on. And this leads to the condensing of the amount or the reduction of the amount of categories. And then I use a different formula. I wanted to have this very robust. Then I'm using a different formula which literally just looks let me show one thing. So since this is the complete output, and then the category mapping maps the high number to a lower number, actually the lower number shows up more often. So other public spaces, other urban regeneration, that all doesn't make sense. What I want is public spaces, urban generation, and other. So the next step is to have another formula looking at those results of the category mapping. And what I'm saying here is get the category mapping, find unique values, sort them A to Z. It beautifully puts them also here in these in this output format, which works well. And this is the A to Z mapping. That will make it easier for a human reviewer to go through it, because we had this review step in between. And from here, one last step that's also a formula is, because when we find this is what the target account is working on, these are the three major categories within that, and which one of these, which will be different for every account or for most accounts, which one of these is the most important to us, that's again a formula. And the way this works, you need to give really, there's no interpretation here. This all has to be prescriptive. In this case, the prompt is get category mapping A to Z. Maybe that wouldn't even have been necessary, but I think it's still a good illustration. I think I can skip this step. Anyways, what I ended up saying is get this data and then go down the list below. Print the first one you encounter in the data. I probably wouldn't even have to put it in here, but it works. I'm not going to change it. And that is master planning 1, urban design 2, public spaces 3, civic 4. So whenever it encounters master planning, this is what it will output and stop. Whenever it doesn't encounter any of these, but for example landscape, then it will output landscape. And that is just extremely powerful, very robust, because it will always produce the same result because it's not LLM based. The prompt, translating that prompt to the actual formula, which is seen here, that is LLM based. Translating the prompt I wrote into this is LLM based, but that the formula itself, which is what's executed, will always produce the same results. And I just want to recap that because for me, that's so mind-blowing that this is possible. We take a company domain, we do a Google search to find the best source on that company website, which is in our case, for what we want to do, the company projects they are working on. We give an LLM prompt a defined set of about 120 categories. They need to categorize the projects they are finding on that source. we give the AI agent, the Claygent in this case, the context that it knows a lot about architectural design, so it can make those judgments at scale. But because we give it Rails, it doesn't come up with like super crazy stuff. These Rails coming from my client are really important to produce good results. This is the prompt for that. And then from here on, we use formulas in order to condense that amount into a smaller amount of categories, select the highest priority out of those, and this will be the outcome delivered for the client. If there are questions, just find me on LinkedIn, and then I'm happy to go through it in detail.